Welcome back to another video. Now in this video we will take a look at how to plot any kind of graphs with the Python framework Kivy, which we can then deploy on an Android smartphone. You should be familiar with Python and have some really basic knowledge about Kivy. The app which we will create plots a simple sine wave. And we can change the frequency of the sine wave with a slider. And we can also zoom in, move the graph around, and zoom out. And that's it. It doesn't seem so complicated, so let's just dive into it. As my setup, I usually use Ubuntu with PyCharm as my IDE, with Python 3.8 and Kivy 2. But for this video, I will be using Windows 10 and also PyCharm as my IDE. The community edition of PyCharm is free and offers a really solid IDE for Mac, Windows and Linux. It also provides built-in support for versioning like Git or Subversion. I install Python simply by using the installer from the website, and if installed correctly, I simply can use the package manager which comes with Python, which is called pip, and install all my libraries. Let's first check if Python is installed correctly. And we can see here Python 3.8.1, and the package manager, like I said, is called pip. And there's also a different, you sometimes write it just like this, pip, or sometimes also pip3. pip3 is for Python 3 because there's also Python 2, but Python 2 is not supported anymore. It's an old version. Now, if we have the package manager here, and for example, if we want to install Kivy, we just simply type in install Kivy. Then we hit enter, and I already have installed it, but in your case, it will install Kivy. And that's it. And this is how you should install all your other libraries on Windows. You can also install it with PyCharm. It has a built-in feature for it, but in PyCharm it doesn't work always. It's much easier with the command line. I also provide all needed commands and links for some error handling in the description below. I'll give you now a very short summary of how Kivy works. To create a graphical user interface with Kivy, you use the widgets. A widget can be something like a label or an empty box. All widgets are organized in a tree, which basically means there's a parent widget, and this parent widget has many child widgets, and those child widgets can also have their own child widgets. All widgets are controlled with the Kivy language, and this can be done in Python itself or in an extra Kivy file. Now, how do we plot the graph in Python with Kivy? When you think of plotting graphs with Python, you probably think of the popular library Matplotlib. Matplotlib works with Kivy, at least on Windows and Ubuntu, but it's not supported on Android. So we will need an alternative in this case. Luckily, there is a widget for Kivy, which is simply called graph. We have here our basic Kivy application, a Python file with some really basic code and an empty Kivy file where we later will control our widgets, give them a color, give them a size, and so on. We have here the main app, the class main app, which has a build function, and it returns a class, an object of our main grid class. And the main grid class inherits from the widget class box layout. And here we simply print hello world. And with this line we run the app. Then we just hit on run, and we can see our Kivy application works. Now there's one thing to mention. If you are working with a Kivy file, then if it's called like your main Python file, then you don't need to import it. You don't need to write import Kivy file. It will automatically search for a Kivy file which is called main and import it automatically. Now I renamed our class to plotter. Okay, let's add some widgets. I want to have the hello world not on my console. I want to have it on my Kivy application. Let's say I want it right here, in the middle of the first half of my Kivy application. Now I declared this class, and which inherits from the widget box layout. Now in my Kivy file, I access this class by writing those brackets and simply like this. And then I can add the first widget which we will add is another box layout. And I can give a size. It's called size underscore hint. And it has two values, an X value and a Y value. And I will set it to 1 and 1. This basically means 100% on the X and Y axis. Like I said before, the widgets are organized in a tree. This will be my parent widget. And now I need to add a child widget, and I will add a label under my box layout widget, and I will add the text attribute and write hello world. Save it and run it. Let's see what happens. It's currently now in the middle of the screen. We want to have it in the first half of our application. So I will add another box layout widget, and this one I will give 1 on the X and 0.5 on the Y axis. And I need to make the orientation to vertical. Same on this. Which basically means it will position those box layouts vertical. If I now place my label inside this box layout widget, I think we will need an additional box layout widget. And size hint again. Also orientation vertical. Let's see what happens. Yeah, perfect. Okay, now let's do some serious shit. Let's add a slider. I will add the slider in the second half of our Kivy application. For that, I will simply write slider, give it a min value. I will set it to 1. And the max value, I will set it to 20. And I can also set the step size, set it to 0.5. And that's it. Let's see what happens. Okay, there is our slider. We also want to see what actual value we have selected with the slider. So we can add a label on top of it. There we have the text property. But first we will need to give our slider an ID. You can give every widget an ID and access it with this ID. I will call it frec for frequency. And then I can access the value of the slider. But because the text property is a string, we will need to convert it to a string. And then I will add hertz at the end of the string and frequency at the beginning. Okay, Pretty cool. As you have seen, the positioning is a bit weird and we need to adjust it. We can do that again by adjusting the sizes of the box layouts. This could be in one small box layout. Let's make it 0.2 and see what happens. Looks even better. 0.1. The thing with positioning in Kivy is you always need to use the whole space. For example, now we have here two box layouts which don't use the whole space. They use basically 60% of the space we have here, because on both axes we have 100%. And if we now add a third box layout inside of our parent widget and set the size to 1 and 0.4, I think this should fix it. Yeah. This is a bit weird, but if you're playing around with it, then you will get used to it. And now we can see it's pretty close on the borders right here. We can add some padding to it on X and Y axis. I will set it to 10. Let's see what happens. Oh, this looks pretty good. Let's set it to 20. Even better. Okay, now... okay, because my padding is now... Because padding makes my box layout larger. And then it will make the actual content smaller, the actual size of the content smaller. So I will resize it, make it a bit bigger. Perfect. Okay. Let's add the graph widget and plot our sine wave. For that, we will need to import the graph widget. And we also need to import numpy. Then I will remove our print hello world and add a constructor. Now I create a variable which I call samples and set it to 512. This will be the amount of values which we will have on the x-axis. Now we will create a variable which we call graph, and we create an instance of the graph widget. The next step, because we need to assign this graph widget to one of our widgets in the Kivy file, and therefore we go to our Kivy file and I will assign it to my box layout. But for that I will need to give the box layout an ID, and this ID I will call graph. Now in the next step I simply can access the IDs by writing self.ids, and then I write the ID of the widget I want to access and write add widget. And here I simply can assign the graph widget. Now let's see what happens. Okay, we have here our graph widget, and later we will see the sine wave right here. For the sine wave, we will need to create a bunch of x and y values. Let's start with the x values. For that I will create a variable, and with linspace from numpy I can create values between 0 and 1. And the third parameter tells me the amount of values which will be created between 0 and 1. Now let's create the y values. And we create the y values by using the sine function. we simply write sine, and inside of the sine function we write 2 times pi times the frequency. I will set the frequency currently to 2. And then we need to multiply it with our x values. Okay. Now we need to create a plot. For that I will create a plot variable and an instance of line plot. Then I declare the color, we'll set it, I think this is a yellow color, I'm not sure. And I also set the line width to 1.5. Now we need to assign the x and y values to our plot. And we do that by writing plot.points. Now this syntax can be a bit confusing. This basically just assigns the y values to the x values of the plot points. You could also write the sine function inside of here, but then you would need to divide it, I think, with the amount of samples. Now the last thing we need to do is to add this line plot to our actual graph widget. Add plot, and that's it. I forgot to set the max values for the graph. So for x, I will set the min value to 0 and the max value to self samples, which is 512. And for the y values, I will set it to -1 and +1. And there we see our sine wave with a frequency of 2. To update the frequency of our sine wave, we will need an update function. I will call it update plot. And we simply need to redo this line here and this one in our update function. Our update function also has a parameter, the frequency, and then we just copy this line and paste it here, and we replace this value with the parameter, and then we will copy this line and paste it here, and that's about it. Now we will need to trigger this update function somehow. For that we will go in our main Kivy file, and we can modify our slider so it will trigger this update function. We simply write on value, which means every time the value has changed, it will trigger an event. And we write root and update plot, and then we set our parameter, which is frequency value, and that's about it. Root refers to the parent widget, which is in our case plotter. So it will access the parent widget and search for a function which is called update plot. So let's see what happens. Let's make our graph a bit prettier. Our graph widget has a few additional properties which we can set. We can set the border color, the tick color, we can enable a grid. Then we can also disable the border. And we can set a label for X and Y axis. And we also need to set the step size for the ticks. So on the X-axis, I will set it to 64. And on the Y-axis, I will set it to 0.5. And this is what we get. These numbers here are the ticks. Then here we have the border color is the color of this grid. And draw border false. This was the border we had at the beginning. Can enable it again. Set it to true. And here we have it. Now we can also add some padding to make it a bit more in the middle. So we go again to our box layout widget with the ID graph. And we add padding, but only on 3 sides, like this. Now it's in the center. Now we are only missing the zoom feature of the graph. Let's start with the buttons. For the buttons, I will create an additional box layout. And I give this box layout an ID, which I will call simply zoom. And the size, I set it to 1 and 0.1. And I set the orientation to horizontal. And then I will create a button widget. This will be my zoom out button. And I set the size to none on the x-axis. And I set the width to self-height, which basically means the button will have the same dimensions on the x and the y-axis. Then I add a label widget, and here I will, later it will contain the zoom factor. Then I add an additional button, which will be my zoom in button. And just like my zoom out button, it will have the same dimensions on the x and y axis. Then I will need to adjust the height of my box layout here. And that's it. Let's see what happens. Okay, let's add some padding. Currently, the background of our Kivy application is pure black, and we can change that. For that, we will need to add a canvas in our Kivy file. And then we simply set the color. And I will choose a gray color. And we need to create a rectangle. And set the size of the rectangle This line basically means the size of the rectangle will be the same than the size of our actual Kivy application. Let's see what happens. Okay. Now we have here this keyword before. This basically means it will render this background color, this rectangle, before everything else. The widgets, which we have here, will be rendered on top of it. We can also set it to after, which means it will render this rectangle after those widgets. The next part is a bit more complicated. We want to add the zoom feature. We currently only have the buttons without any functionality. And to zoom in on the graph, we are going to use the scroll widget. The scroll widget is basically a box layout, in simple terms, which allows you to scroll through the content if the content is larger than the actual box. So basically what we are going to do is we place our graph in a box layout and we make this box layout larger than our actual Kivy application, at least on the x-axis. And we control the size of the box layout with our buttons. We will need to add also a zoom function. Let's start with the scroll widget. We will add here the scroll widget, which is simply called ScrollView. And we will need to give it an ID. I will call it view. And then we need to set some attributes. We only want to scroll on the x-axis. So I set the x-axis to true. And we don't want to scroll on the y-axis. Then we make the orientation to vertical. And we set the size of the scroll view to 1 and 0.5, which will be basically the same size of our box layout where we have currently our graph. Then we set the scroll type. And that's about it for the moment. Now we need to add an additional box layout inside of our scroll view, where we set the orientation to vertical, the size to none on the x-axis and 1 on the y-axis. And then we need to move our box layout with the graph inside of this box layout here. And we need to set the size on the x and y axis to 1 because it should use all the space of the scroll view. You can remove the orientation and also the padding. And now we need to set the width of our first box layout in the ScrollView widget, like this. This will be our zoom factor later, and it will be replaced with a variable which we can change. If the zoom factor is set to 1, then we haven't zoomed in, then it will just look like this. And if we increase this value, we can already see that we have zoomed in, but only on the x-axis. The y-axis remains the same. Now, because we don't want to set the zoom factor manually, we want to set it with the buttons we have created. We need a zoom function. So let's write one. So we go back to our Python file and we write the zoom function, update zoom, and it also has a parameter which we simply call value. And here we will decide, the value is basically the string of our button, a minus or a plus. And we decide if it's a minus, then it should decrease the zoom factor. And if it's a plus, it should increase the zoom factor. And we also will need an additional variable. I will declare the variable and just simply call it zoom. And like I said, zoom should be increased if the string is a plus and decreased if it's a minus. Now the weird part of this zoom factor is that it doesn't work endless. At some point the graph will just show us a black screen. I've tested this many times, and on my Android phone I just could get a zoom factor of 8, and everything what was greater than 8 just showed me a black screen. So we will adjust our update zoom function. So that it will only multiply our zoom factor by 2 if the actual value of our zoom factor is smaller than 8. And here if the zoom factor is greater than 1. Now we need to trigger this function. Like our slider widget, the buttons also have some kind of trigger property. And for the buttons you have multiple options. I think one of them is on release, which just means if you release the button, then it will trigger a function. And again, we need to write root and update zoom in this case. And here we can simply write the value. The same for our zoom in button. And it just crashes. Okay, I've accidentally have written here self.value. I need just to remove it, and then it should work. Okay, currently it doesn't do anything. Because we haven't assigned the variable here. And we just write root and zoom. And this should fix it. There's one more thing we need to do, because you can't just simply access your variables of your class in Kivy. For that, this only works for your functions. If you want to access a variable, then you need to declare a property for this variable. And this property will need to have the same name as your variable, because it's a number we want to assign. I will use the numeric property and set it to 1. Then we need to import it. And now we should get the proper value of it. Yeah. Now we can also add the zoom factor to our label. And because it needs to be a string, we need to convert it to a string. Root zoom. Really nice. Now for the scroll view, we can also adjust the bar, the scroll bar, which you can see here. We can adjust the color of it, the width, and yeah. So let's do this quickly. I will set the bar width to 4, then the bar color to basically white. And then we can also set the color of the bar if it's inactive. And I make it half transparent, like this. Now we can also add some padding. So it looks nice again. Now there's one last thing we need to do. You can see if I zoom in, then this grid is also changing, and it would be nicer if the grid remains the same. And we can do that with a small modification on our code. We can simply adjust the step size of our ticks. And we can do that by simply accessing our graph, then X ticks, major, and like this, and the same for zoom out. We need to divide it here and we need to multiply it here. Right, perfect. So that's it basically.
We are finally done with the coding stuff and can now deploy this app on our Android smartphone. But this will be part of the next video. Congratulations, you made it to the end of this video. And you can also find the code of this tutorial in my GitHub repository. The link is in the description. That's about it, and I will see you in the next video.